Hello everybody, these are the work solutions for 11.2, the lesson on expectation. Question 1. In a particular region, the probability that it will rain on any one day is 0.28. On how many days of the year would you expect it to rain? Well, we're going to use the expectation formula, which is n times p. We have that n is 365 days. We should probably include, though, the extra part for the leap years. So let's say 365.25, and the probability is 0.28 as given. And if we multiply those together, we're going to have 102 days. Question 3. If two dice are rolled simultaneously 180 times, on how many occasions would you expect to get a double? Well, there are 36 different outcomes if you roll two dice together, and there are 6 different doubles. So we've got a probability of 6 out of 36, which is a sixth. So that's going to be our P. We have N is equal to 180. So the expected value is going to be NP, so 180 multiplied by 1 over 6. And of course, that is going to be 30. We would expect to get 30 doubles. Question 4. A single coin is tossed once. If a head appears, you win $2, and if a tail appears, you lose $1. How much would you expect to win when playing this game 3 times? Okay, this is going to be a tough one to draw out. We need to have a good visual understanding of what is going on. So let's start with a tree diagram. So we've got outcomes, head, tail, and then of course we've got head, tail coming off of each of those, and then we've got head, tail coming off of each of those. But the good news is that all of the probabilities for each of these are the same. It's the same, it's a half for each of them. So a half times a half times a half is an eighth. So the probability of each of these events occurring is an eighth. So let's write that down. We've got 1 over 8, 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 and 1 over 8. Okay, so in terms of expectation, well, if a head appears, you win $2. So if 3 heads appear, that's the first line, that's going to be a win of $6. Following on from that, if I get 2 heads in a row, I get $4, but if I then get a tail, I lose one of those dollars. So this is going to be $3. It's going to be exactly the same for any combination of 2 heads and a tail. So we can fill in this one being $3 as well. And we have down here as well another 2 heads. This is also going to be $3 as well. Now, head, tail, tail. Well, we gained $2 on the first head, but then after that lost $2 on the next 2 tails. So our expected outcome from just that particular event occurring is going to be 0. And we can fill in that same 0 here and here because they all mean the same thing, 2 tails and a head. And then finally, if we get 3 tails in a row, we're going to lose $3. So we're going to write -3 there. So in order to work out the total expectation, if we do this experiment, we need to multiply these together and then add them up. So if we keep the denominator as 8, we're going to have 6 over 8 here, 3 over 8 here, 3 over 8 here. We've got a 0. We've got another 3 over 8, a 0, a 0, and finally a -3 over 8. So now what we need to do is to add these up. Well, I can cancel the -3 over 8 with a +3 over 8, and we're going to be left with 12 over 8, which simplifies to being $1.50. Next question. Question 8. A charity fundraiser gets a license to run the following gambling game. A die is rolled and then returns to the player are given in the pay table alongside. So let's look at that. So we've got a result of 6 wins $10, a result of 4 or 5 wins $4, a result of 1, 2, or 3 wins $1. What are your chances of playing one game and winning? Well, first of all, $10. Well, this looks quite simple. Of course, it's a 6, so it's going to be 1 out of 6. $4, well, it's a 4 or a 5, so that's 2 possibilities out of the 6, which simplifies to a third. And then, of course, $1, well, we've got 3 different possibilities, so that's going to simplify down to a half. B, your expected return from throwing a 6 is a 6 times 10. So what is your expected return from throwing a 4 or a 5? Well, a 4 or a 5 has a probability of a third, and we're going to get $4 there. So we are looking at 4 times a third, which in terms of dollars is $1.33. A 1, 2, or 3, well, that chance is going to be 3 out of 6 or a half, and we're going to get $1 there. So we are ending up with 50 cents. A 1, 2, 3, 4, 5, or 6, well, we're going to need to combine those things together. So we're going to have a 6 multiplied by 10 plus a third multiplied by 4 plus a half multiplied by 1. This comes out at 3.50. Okay. Next one. C. What is your overall expected result at the end of one game? Well, for this, we need to make sure we remember that the game costs $4. So if our expected outcome without that cost is $3.50, as we worked out on the previous example here, then we can do that $3.50 minus the $4, and we are looking at losing a loss of $0.50 or 50 cents. D, what is your overall expected result at the end of 100 games? Well, we're going to multiply the number of trials N by that loss per game, I guess. So that's going to be multiplying by 0.50. So we're looking at a $50 loss to play 100 games. Question 12. A random variable x has a probability distribution given by the p of x equal to the x equal to x squared plus x over 20, for x being 1, 2, and 3. Calculate the mean for this distribution. So this is code for calculate the expectation. So let's start with a table. We've got these x values equal to 1, 2, and 3, and then the probability that our discrete random variable is equal to these x values. Well, if I substitute 1 into that, we're going to have 1 squared plus 1 on the top, on the numerator. That will be 2 over 20. If I substitute 2 in, I'm going to end up with 6 over 20. If I substitute 3 in, I'm going to end up with 12 over 20. So now I need to multiply these two values together and add them all up. So x, probability of x equal to x. Well, 1 times 2 over 20 is 2 over 20. 2 times 6 over 20 is 12 over 20. 3 times 12 over 20 is 36 over 20. I now need to add these up, and if I add that up, I'm going to get 50 over 20, which of course is 2.5. Our mean for this distribution is 2.5. Question 14. Okay, this looks difficult. At a charity event, there is a money-raising game involving a pair of ordinary die. The game costs $80 to play. When the 2 dice are rolled, their sum is described by the variable x. So first of all, sum means add the numbers on the 2 die. The organisers decide that a sum which is less than 4 or between 7 and 9 inclusive is a loss of A over $3. A result being 4 and 6 is inclusive, gives a return of $7, and a result of 10 or more gives a return of $21. Determine some probabilities. Okay, for this, we're going to need a table to work out the chances of getting various things. So again, we've done this in a previous video. We're going to have to write this out again. And we're adding, as we said earlier, so let's quickly jot this down. 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12. So this is our sample space diagram that represents the 36 different outcomes when we add two die scores together. So to determine the probability that we have something less than or equal to 3, well, if you count them, we have got 1, 2, 3 of those out of our 36. So we are going to have that the probability of x less than 3 is going to be 3 over 36 equals 1 over 12. The probability that we are between inclusive 4 and 6, well, let's work that out. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 12 out of 36, which is, of course, a third. The probability that we are between 7 and 9, well, we can work that one out as well. Between 7 and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We are going to have 15 out of 36. 15 out of 36 is, of course, 5 over 12. And then finally, the probability that we are greater than or equal to 10, or we can count the remaining ones. There's going to be 6 there. 6 out of 36, which is, of course, a sixth. B. Show that the expected gain of a player is given by 1 over 6, open bracket, 35 minus 7A dollars. Expected gain of a player. Well, first of all, shall we find that the EX? Let's not worry too much about how much it costs to play. Let's just think about, for each one of these things, what's going to happen. So, if we start off with the probability of it being less than or equal to 3, but we know that is 1 over 12. And if we think about that, and we also know that as well as that being an outcome which generates one particular score, we also know that the between 7 and 9 is kind of the same, right? So the 7 and 9 is 5 over 12. So let's add those together. Right, so we can see already that's going to be a half. Now, if that happens, any of those things happen, we are going to get an outcome of a loss of A over 3. Right, let's put a minus sign in there as well. Okay, let's go back and read out what else happens. So we've already sort of taken into account the loss of A over 3 happening if we're between 7 and 9 or less than 4. That's been done. So the next one. If we've got between 4 and 6, we're going to gain 7. So let's look at our 4 to 6. Well, that was a third. So we get to work out our expectation. We're going to have a third multiplied by what we get 7, don't we? So we're going to do a third times 7. And then finally, we have, if we get a 10 or more, we get 21. Well, probability of getting a 10 or more, as you can see, is 1 over 6. So we've got to add to this 1 over 6. Multiplied by 21. Now, let's add this up. So if we add this up, we're going to get, well, the first thing we said already that we've got a half here. So we've got a half times negative A over 3. So we've got negative A over 6. Plus a third times 7 is 7 over 3. Plus a sixth times 21 is, of course, 21 over 6. And if we write that 7 over 3 with a denominator of 6, we can simplify even further and write it as minus A over 6 plus 14 over 6 plus 21 over 6. And then if we take the factor of a sixth out of that, 1 over 6, which looks looking good as in terms of what we've got to get to show, we'll be left with 35 and a minus A after that factorization. So that is the kind of expected value, but we haven't yet taken into account how much it costs to play. So it costs, I should say, $A to play. So if that's what you gain on average, we've got to take away the cost. So we're going to end up with a sixth of 35 minus A minus A. Now, That doesn't quite look like it's supposed to. We are aiming for a target. We're showing that we are at a 6, 35 minus 7a. But we need to bring that a into this bracket. Well, we could write it with a denominator of 6. So we could turn it into a 6 35 minus a minus 6a over 6. That's going to be the same thing. Now we've got that 1 over 6 involved. We can include that in the bracket. We're going to have 1 over 6, 35 minus, and we've got the minus a, but we're going to have another minus 6a in there. So we'll have 7a in total, and that is what we're supposed to have, a 6, 35 minus 7a. Let's carry on. Now, C. What value would A need to have for the game to be fair? Well, a fair game means the outcome is 0. So if this is our expected outcome after that payment's been made, then we can say, this is C, a 6th of 35 minus 7a needs to be 0. So if we multiply by 6, we're still going to have 0. So we're going to end up with 35 minus 7a equals 0. If we add 7a to both sides, 35 equals 7a. So therefore, of course, a is going to need to be $5. D. Explain why the organizer would not let A be 4. Well, of course, they would lose money if it cost $4 to play. If we substituted in A for 4, so a 6 lots of 35 minus 7 times 4, that would give us 7 over $6. They would lose $1 over $6 per game, so they would not like that to happen. E. If the organisers let A be 6 and the game was played 2,406 times, estimate the amount of money raised by this game. Okay, so A is 6. What would happen? Well, we're going to have a 6, 35 minus 7 times 6 being the outcome. In terms of the customer, that means a loss of minus 7 over $6 this time. So if that happens 2,406 times, we're going to need to work that out as a multiplication. So you've got your outcome, and we're multiplying that by 2,406. That will be an outcome of a net loss to the player or a gain to the organizer of $2,807. There we go. That was quite the question. Right. You hopefully have all the information you need and have understood that. I'll see you on the next lesson.